Hi guys, this is Vectors Day 1. This is going to be kind of a rambling video. What I'm really going to do is just kind of try to talk about the PDF that's in the in the Schoology folder. So if you read through that PDF and you don't quite understand it, this is the video to watch. So we're talking vectors. Vectors, according as is in our notes, it's a quantity that has both magnitude and direction. Usually what you do is you represent it with an arrow. You'll see that most of the stuff that I write, that I don't write the arrow, I apologize. You can also represent it with like capital letters to an arrow, and what we have is we have algebraic representations and we have geometric representations. So like if we are in the coordinate plane and I say, okay, I'm starting at this point and heading toward that point. So like if I go A, B here, that is vector AB because it has a length and it has a direction. So, and that's different than if I were to say, hey, actually, let me do it this way. That's different than if I were to say, hey, let's start at B and head towards A. The vectors would have the same length, but they'd have different directions, so they're not the same vector. There are multiple ways that you can describe or algebraically write a vector. The most common way is component form, AI plus BJ. The I just represents the horizontal distance, and the J just represents the vertical distance. Okay, so like let's say I have 3I plus 4J. That really just means I've moved 3 to the right, 4 up, but the actual vector itself would be from the origin to that endpoint right there. Okay, so that would be the vector, but it's made up of the two components, the horizontal component and the vertical component. You can also, another way to write that would be 3, 4 with like little, they're not parentheses, they're like, I call them just little arrow parentheses. So that's another way to write it. You could have also, say, hey, I've got a vector that starts at point P, which is at 7, and goes to Q, which is at 12, 9. I mean, it's just, I'm just making up numbers. So you could have, there's your initial point, there's your terminal point, and then you can use that to actually write the vector. Okay, and so you went from 3 to 12 is 9, from 7 to 9 is 2. So it can be written as 9, 2, or it can be written as 9A plus 2J. So there's just multiple ways to write it. The length of a vector, let me go to a new screen. The length of a vector is the magnitude. Okay, so the magnitude is the length. It's also when we get further along, we'll have the magnitude as far as force vectors. It's usually like the amount of weight of something or the amount of force that's being pushed onto something when we get into the applications. So the best way to look at it is, again, I'm just going to use, I'm going to use the one that I just kind of drew, that 3I plus 4J, right? So we know that it's here, and our horizontal component was 3, our vertical component was 4, right? 3I plus 4J, or we could write it 3, 4, right? Or we could have said, hey, A is at the origin, and B is at 3, 4, so the vector AB is represented by that. You could also just name it vector V if you wanted to. It doesn't matter. But anyway, the magnitude, guys, if you stop and think about it, just like pretty much everything else we do in this semester, it all comes back to kind of like right triangle trig. The magnitude is just, we're going to use the Pythagorean theorem, basically, is what we're going to use. So your magnitude is really going to be square root of A squared plus B squared. So the magnitude in this one would be 3 squared plus 4 squared, or square root of 25, which is 5. Okay. Let's see. You can add and subtract. I'm trying to like just kind of scroll through the notes that are in Schoology just to kind of see what I should talk about. That's really like, as with everything that we're doing with this online stuff, we're not going into as much detail as we would normally. So I'm trying to just hit the stuff that you would really, really need. Okay, we'll talk geometric real quick. So, well, I'm not going to talk geometric. What I'm going to talk is algebraic. So you can actually add or subtract vectors. So let's say I have vector u is 7i plus 3j. Vector v is negative 2i minus 5j. Okay. If I wanted to add or subtract it, u plus v, when you're adding and subtracting, all you're doing is basically combining like terms is really what you're going to do. You're going to take the horizontal components and combine them, and you're going to take the vertical components, not components, components and combine them. So for u plus v, it's really just going to be 7i plus a negative 2i, right? Plus the 3j plus a negative 5j, right? You are honest to goodness just kind of, and honestly, you could have just done it right there and just 7 minus 2 is 5i. 3 minus 5 is negative 2j, sorry. So you would get the same thing though, but 5i and then negative 2j. Okay, so you're just combining like terms. If I was subtracting, we'll go with that. If I was subtracting u minus v, it would be 7 minus a negative 2. The other way you'll see it written is like this, where you actually just write the two numbers in parentheses, I plus a 3 minus a negative 5j. And so 9i and an 8j. The other thing I want to talk about is scalar multiplication of vectors. So like, let's say I wanted to do, why does my purple keep going over? There it is. Okay. So let's say I wanted to do 5u. Honestly, guys, it's really simple. All you're doing is taking that 5 and you're distributing it across. So it's really 35i plus 15j, right? Because 5 times 7 and 5 times 3. All right, one more real quick thing, because there is something on your my math lab that takes a look at the geometric representation. So let's say that we have vector u. I'm not going to write anything. Let's say it's just that vector is going that direction. And let's say we have vector v, and let's say that vector is going that direction and is roughly that long. So this is kind of where I miss my smartboard, because I could really just pick them up and move them to where I wanted them to be, but I don't think I can do that. So if I want to do u plus v, the geometric representation would be, so when you're adding vectors, basically you would draw the first one, and let's hope that's the same length, and I hope you get what I'm trying to do. So you had started here, you've gone in this direction, and this is where you're stopping. And then when you add the second one, what you do is you just, where you stopped for the first one, you are going to continue with the second one, and I'm going to try to make it look like it's basically the same length. Again, if I had my smartboard, I would just drag and drop it, but I don't. And so what ends up happening is, from the initial start point to the now end point, that vector right there, the resultant vector, that is u plus v. And I just wanted to do that real quick, just because there's a few of them on my math lab that I really like them, just because it's, it's a different way to represent them. It's the geometric representation of them. I think it's important for you guys to kind of visualize that. They're not really difficult. You just kind of have to visualize them. And it's nice because my math lab basically shows everything else. All right, I think that's it. Again, the PDF is very detailed. You can read through it. I just wanted to kind of talk through some of the high points for it, or the important points for it. The only other thing that's at the very bottom of that PDF is unit vector. So unit vector is really just a vector that has a magnitude of 1. And to find a unit vector, you're just going to take the vector itself divided by the magnitude. And that's, I do that on day 2 video. So if you need to see calculations for that, it's actually on day 2. Okay, that's it.